All right, hi everybody, welcome back. So in the previous section, we talked about finding max or mins with a graph. But now what if we actually don't have a graph, right? How do we find these max or mins, right? So since the relative minimum occurs when the values of f, which was decreasing, then begin to increase, we then look to the derivative for this information. We use a derivative, like just like we did in the warm-up example where we took the derivative, set it equal to 0, and we are able to obtain our minimum value, min or max value. Okay, then it's just a matter of determining like, was it a min or is it a max, right? So here's a way to do it called the critical value. That's the actual definition of that. So critical value of a function f is an x value, right? In the domain such that if you set that equal to 0, um, or this x value makes the derivative equal to 0. Okay, and then the way to determine if it's a max or min is the first derivative test. So if the derivative changes from positive to negative at this value, then it's a relative maximum, right? That means it's going up and then down, right? Positive means up, negative means down. And likewise, if f changes from negative to positive at this x value, critical value, then f has a relative minimum, right? So this means going down and then up, right? Looks something like that. So lastly, if f does not have a change of sign, then it's not a max or min. This is a little more uncommon, but it might happen. But anyways, let's go ahead and check out an example. So I don't want to do example two uh, because it would be trying to factor a cubic function. It would be a little more involved than I would like you guys to do. So let's go ahead and jump to example three and try this out. So example three is saying find the intervals of increase or decrease for the function f of x equals x cubed minus 12x plus 2. So it's one thing we got to do. We got to find the intervals of increase or decrease and then find the max or min. Okay, so there's always a step-by-step process when you have to figure this out. And I'm going to write it up here, right, for our room, for having room. But first thing I always want to do is find the critical values. So step one, find critical values. All right, that's my step one. So what does that mean? So I have my function f of x equals x cubed minus 12x plus 2. And to find a critical value, I need to find the derivative and set that equal to 0 and solve for that. So what I have here is the derivative is 3x squared minus 12. Okay. And so I want to set it equal to 0 so I can solve for x. So I'll make a note here. Set the derivative equal to 0. So then I'll have 3x squared minus 12 equals 0. And I'm just going to solve for x. So I move the 12 to both sides, right? Plus 12 plus 12. I get 3x squared equals 12. Divided by 3 to both sides. I'm solving for x. So I get x squared equals 4. And then I'm going to take the square root of both sides. So what I'm left with is not just 2. When I take a square root, I end up with plus or minus 2. Okay. You get two values when you take a square root, a little bit of algebra refresh, but what this means is my critical values are x equals 2 and -2. I write it like this. And x equals -2. Okay, so that is a way to find your critical values. It's always the first step you do. So let me go ahead and close this off. So to move on to step two. And step two is always going to be finding using your number line to determine if you're using a max or min. So what I mean by that, so what you literally want to do is draw a number line like so, right? And you want to put your critical values here, right? So here's like, say -2, here's like +2, and let's go ahead and fill out the rest of this number line. So, or I'll leave it like this for now. But what you essentially want to do is test out points to the left, to the right of these guys, of these critical values, and see if you get a positive or negative value. That way you can know if you're increasing or decreasing. So what we're basically going to be doing is using the first derivative test. So number line, first, we're going to like this. First derivative test. Okay, so what I want to do is pick numbers, easy numbers to work with, so that when I plug them in, I can get a solid answer. So what I'll do here is like test point, where I'm just going to test points and plug them into my first derivative, which is this guy right here. Okay, so I'm going to test some points and see what we get. So I'm going to plug, you can pick whatever numbers you want, just for your own sake, pick some easy numbers. So I'm going to pick like -3 here. I'm going to pick 0 here. 0 is always easy to work with. And I'm going to pick 3. So, all right, so I'm going to take these numbers and plug them into my first derivative. So I'm going to plug them into f prime of x equals 3x squared minus 12. I'm plugging them into that. So I'm going to take -3 and plug it into this. So I get 3 times -3 squared minus 12. And if you do the calculations, right, -3 squared is 9. 9 times 3 is 27 minus 12 is 15. So I get 15, right? The actual number is not important. What you really want to know if it's positive or negative, right? Because that's what we're finding right here, positive or negative. So we get 15. This is positive. So what that means is I'm increasing there. So I'm going to go here and write my arrow going up. I'm increasing. Okay, so let's go ahead and check out the next one. I want to try out 0. Once again, you could choose anything you want. You could have chosen -1 or 1 or 1/2, but 0 is just always easy to work with. And I'm going to plug that into my derivative. So I get 3 times 0 squared minus 12, which is just -12. And this one is negative. So what this means is, I'm going to write negative. What that means is you're going down. You're decreasing. So I'll write here on the number line, my arrow going down. Okay, so last one, try out number 3, or sorry, x equals 3. So let me go ahead and plug that into our derivative as well. So 3 times 3 squared minus 12, we should get the same thing as above because they're squaring the 3, and we get 15, which is also positive. So we're going up. Let me rewrite this down arrow. Okay, so we're going up at 3. So essentially, what this means is I'm going to have a max right there. I'm going to have a min right there, just how our arrows are going. right? So it's good to make the arrows so we can visually see what's going on. So let me use a different color, but this is actually looking like this, which is a max, and looking like this, which is a min. Okay, so what does that mean in terms of our increasing or decreasing, right? Well, now we actually have a visual representation of the increase or decrease, right? So remember, we're going off to infinity that way, going off to infinity that way. So the way I would write this increase is, right? We're not just at -3. It's coming from this way. It's going forever. There's no stopping point. So the way I would write this is increase is coming from negative infinity, right? We're coming up, oops, we're coming up and we're stopping at -2. So it'll be from negative infinity to -2. Where else am I increasing? I'm increasing from 2 to infinity as well. So it'll be 2 to infinity. And I'm decreasing, right? Where am I decreasing from? Well, I'm decreasing from -2 until 2. So decrease would be -2 to 2. Okay, so just be careful. Don't write your numbers you're testing out as an easy mistake. Always use your critical values. So let me write that note. Use your critical values. Okay. Don't use the ones in purple. Okay. All right. So that is finding increasing and decreasing, right? Next part of the question is determining the max or min. So sometimes it might suffice just to say what your max and mins are. Like you could say, well, my max is x equals -2, my min equals x equals 2. But sometimes maybe you would want an actual coordinate point. So what we have to do here is plug in our critical values, right? Plug these guys back into our function to get our actual y value, and then we get the coordinate points. So kind of say this is like step 3-ish. So step 3, find y values of critical values. Okay, so what I'm going to do is just take these, um, critical values, CV, x equals 2, and -2. I'm just going to plug these back into our original function to get the actual coordinate point. So f of x, the function is right here. So I'm just going to plug them into that guy. So if I plug in 2 into that, I get 2 cubed minus 12 times 2 plus 2, and I get 8 minus 24 plus 2, so -14. And if I plug that into plug -2 in there as well, I'm going to get something different because of odd powers. So what I end up with is 18. Okay. So I know here at -2, it's a maximum just by the way my first derivative test went. So what this means is I have first, let me rewrite this as a coordinate point. So it's the coordinate point 2 comma -14 and coordinate point -2 comma 18. So kind of my solution is I have a relative max at, we said, at -2. So relative max at -2, 18. And relative min at 2, comma, -14. Okay, so that is how you would do this problem. So let me go ahead and circle our correct answers. And also, intuitively, you know which one could be your max or min because this y value 18 is greater than this y value -14. So that's also an easy way to check if you're not understanding the number line too correctly. Okay, so that's the example. We're exhausting everything we kind of just picked up right now. We have our two answers, increase and relative mins or maxes. So let's go ahead and move on to another example, right? But what if we are on a closed interval? Kind of what we saw in this example here. What if it's a closed interval, right? We don't have a graph though. How do we find the mins or maxes of that? So there's an easy way to do that. So, we have this example here, right? Here's a step by step. We'll go over that in a second, but here's an example right here. First thing you want to do is find all critical values in this closed interval. So step one, same thing. You got to find the critical values. So find critical values. And what that means is I got to find the derivative. So f of x equals x cubed minus 6x squared plus 9x plus 2. I got to find the derivative of that, which is 3x squared minus 12x plus 9. Okay, so remember, we got to find the critical values, and that means setting the derivative equal to 0 and solving. So I'll say set the derivative equal to 0. So 3x squared minus 12x plus 9 equal to 0. So I got to factor this thing. Okay, so luckily we have a common factor that's easy to work with. So I can factor out a 3 from all of these. So I'm going to factor out of 3. I'm left with x squared minus 4x plus 3 equals 0. And then I can just, divide by 3 to both sides and get x squared minus 4x plus 3 equals 0. All right, so finishing out my factoring, right? This is the way I was taught. You might do it differently, but the way I factor is I want to find two numbers that multiply to 3 and add up to -4, add or subtract. Okay, so multiply to 3, add up to -4. Those two numbers are -3 and -1. So this thing factors into x minus 3, x minus 1 equals 0. Okay, so then respectively, I just solve for x, and I get x equals 3, and then x equals 1. So critical values are x equals 3, x equals 1. Okay, so that's the first part of finding it on a closed interval. Second part is what we want to do now is just plug in the endpoints of that closed interval. So what we're going to do now is plug in 0 and 4. Okay, so what I'll say for step 2, evaluate at critical values and endpoints. All right, so I'm just going to plug in our critical values and endpoints into the function and see basically what's the biggest value to see our max or mins. So let's go ahead and do that. So my first endpoint is 0. So f of 0 is 0 cubed minus 6 times 0 squared plus 9 times 0 plus 2. And what I end up with is 2. So I have the coordinate point 0, comma 2. Okay, so that's our first endpoint. And then our second endpoint is 4, right? So we'll get 4 cubed minus 6 times 4 squared plus 9 times 4 plus 2. And if you calculate all this, what you'll end up with is 6. So you'll end up with the coordinate point 4, comma 6. All right, so that's our endpoints, right? We're plugging in these guys here. Now let's go ahead and plug in our critical values that we just found. So f of 1 is 1 cubed minus 6 times 1 squared plus 9 times 1 plus 2. And if you calculate all this, you should end up with 6 again. So you get the coordinate point 1, comma 6. All right, so last one is 3, and you get 3 cubed minus 6 times 3 squared plus 9 times 3 plus 2. And if you calculate all this, you also end up with 2 again. So you have the coordinate point 3, comma 2. And so realistically, you're getting the same type of max or mins. So you would have a absolute max at y equals 6 and absolute min at y equals 2. Okay, so since we have the same, oh, excuse me, what we do know is that from above, that relative max mins can be endpoints, right? So that means our endpoints need to be our absolute maxes. So just to kind of finish this out, our absolute max or mins are coming at our endpoints. So absolute max at 0, comma, sorry, at 4, comma 6, and absolute min at 0, comma 2. Okay, so that is how we would do on the closed interval. But that's it for this one. We'll see you next time. Thank you.